Welcome back. In this video, we're going to take a look at a cool way that we can actually perform ARP spoofing or ARP poisoning manually. We're going to do that using a huge library that comes with Python 3, and that is called the Scapy library. Now, Scapy allows us to manipulate different networking packets, and we can also send and receive the packets as well. Now, we could do something like this with the help of a socket library, but that would be much harder. Because with the help of Scapy, we have all of the packets already predefined, and we can just craft them to our liking. Now, the same way that you can open Python inside of the terminal, you can also open Scapy inside of the terminal. And this will allow you to write the code line by line. So it will take a few seconds to open this framework, and once it opens up, you will see this Scapy banner, and then you will be able to run the commands right here. Scapy works similarly to Python, so you can use the print statements to print hello world, for example, and it will also run that code as well. However, we're not going to use it for this. We're going to use it to craft packets. For example, there are attr headers inside of a packet, and to see all of the fields that an attr header has, we can type ls and then attr. The same way we can do for the ARP packets. For example, if I type ARP inside of the brackets, it will give me all of the fields that an ARP packet has. And you can do that for any packet that you want. For example, you can also do it for TCP packet, and it will give you all of the fields that the TCP header has. And then you can change each of these fields to your liking. But as I already mentioned, the goal for this video is for us to craft an ARP packet that will poison the ARP cache of Windows 10 machine, and that will tell our Windows 10 machine that we are the router. So how can we do that? Well, first, if you remember, we must know the MAC address of our Windows 10 machine to be able to send the ARP poisoning packet to it. Now, we're not going to cheat and check out the MAC address inside of the command prompt on Windows 10. We're going to get it using Scapy. To do that, we must send an ARP request that we request the MAC address of the Windows 10 machine. To do that, we must also send that request to the broadcast MAC address, which, if you remember, means that every machine on the network will receive that request, and then hopefully our Windows 10 machine will reply with its MAC address. So to do that, let me see if I can use clear command right here. Okay, great, I can use it. To do that, we are going to combine the attr header that we just checked out with the ARP header or the ARP packet. The reason we need the attr header is so we can specify the destination MAC field to be the broadcast MAC address. Therefore, our ARP packet will be received by anyone on the network. Let's do that. So let's create a variable called broadcast, and this variable will be equal to attr header, and the dest field, which is the destination, we can set to the broadcast MAC address, which is for everyone 6 times FF separated by 2 dots. Once you do that, you can close the brackets, and now we got our broadcast packet ready. To check out whether everything is selected correctly, we can type broadcast.show. And this will show all of the fields that we have right here. And you will notice that it will automatically set the other 2 fields. This is the MAC address of our Cal Linux machine, which is the source MAC address because we're sending the packet from our Cal Linux machine, and the destination is to who we are sending the packet. In this case, we're sending the packet to everyone. Now what we must do is we must also create the ARP layer to this packet. And to do that, we can type ls-arp first to check out all of the fields, and we want to target the Windows 10 machine because we want to get its MAC address. So what we must do is we must type the p destination to be equal to the IP address of Windows 10 machine. All the other fields will be set automatically for us, except this hardware destination field, which is the MAC address of our target, which we get from the ARP response. So to craft the ARP layer, we can type ARP layer equals and then ARP, and inside of the brackets we specify the fields that we want to use. In this case, we only specify the p destination to be equal to 192.168.1.7, or you can just specify the IP address of your target machine. Press enter, And before I explain this, I can just type arp.show to show you how the packet looks like. So it will select the hardware source to be our MAC address. It will select the P source to be our IP address. It will select the P destination to be the target's IP address, which in our case is 192.168.1.7. And the hardware destination will be empty because this is the value that we want to get back. This packet is essentially saying, who has 192.168.1.7, give me your MAC address. And to combine this packet with our broadcast layer, we can type entire underscore packet equals broadcast/arp layer. And this will put our two layers together. If I type entire underscore packet.show, you will see we have both the Ethernet layer and the ARP layer. Only thing we must do right now is we must send this packet to our network. We can do that using SRP function, and this function takes arguments of entire packet. We can also set the timeout to be 2, and we can set the verbose to be equal to true. Now, this is not something that we want to send. We want to store the response inside of the answer, because if the Windows 10 machine answers, we will have our answer with the Windows 10's MAC address right here in this variable. We also want to only get the answers and not the unanswered packets, and we can do that by specifying right here 0 to select the first element inside of the list. Once we do that, we can press enter, and we get operation not permitted, and that could be because we are not root account. So what I'm going to do is I'm going to run this real quick as root. So I'm just going to write all of the commands that we just did, and I will get back to you as soon as I get to the SRP command. Okay, so here we are. Now we made a mistake that I already talked about. We must run all of this as a root account, otherwise some of these commands will not work. And I just typed all of the previous commands that we did, such as setting the broadcast layer, ARP layer, and creating the entire packet. And now we're sending the entire packet with this command, and we're storing the response in the answer variable. So let's press enter, and it will tell us finished sending 1 packets, received 1 packets back, and got 1 answers. Now to get this answer, it's a little bit tricky. So if I type print answer, we will get this response right here. And since all of these are empty, we want to select this other part right here and print just that part. To do that, we can type print answer and then the first element, which will be the answered packets. So in the brackets, we specify 0, press enter, and this is our response from the Windows 10 machine. If we take a look at the response right here, we're going to see the MAC address of Windows 10 machine. So we successfully received it with our packet. Now, we can either copy it from here and store it in a variable, or we can select it like this. So we're going to print the answer, and from the answer we are selecting the first element, and from the second list we are selecting the second element, and we're going to type .hwsrc. And the reason we are using HWSRC is because this is the field that has the MAC address of our Windows 10 machine, or of our target machine. Then if I print this, it should print just the MAC address, and here it is. And all we need to do right now is copy this and store that in a variable that we can name target MAC address equals, and then our answer with the HW source field. Great. Now we got our target's MAC address, and we are ready to craft the malicious ARP packet. So what we can do is we can type something like this. The packet will be equal to ARP packet, and we're going to select the OP field to be equal to 2. Now if you type ls_arp, you're going to see the OP field, and this OP field is simply just asking, are we sending ARP request or ARP reply? Once we select the field to be equal to 2, this means we're sending an ARP response. And remember, to send a malicious ARP packet, it must be an ARP response, telling the router that we're Windows 10 machine or something similar to that. Once we set the OP to be equal to 2, we must set the hardware destination to be equal to target_MAC_address. And from here, we are selecting 2 more fields, which are P destination, to be the IP address of our target. So this simply means that we are sending this packet to our target, And the last part is where we add the malicious thing. Here under the P source, in a real packet, in real communication, we would specify right here the IP address of our Kali Linux machine. But in this case, we want to pretend that we are router. So we're just going to specify the IP address of the router. And this right here is our malicious packet. If I type packet.show, you will see it right here. We have the MAC address of our Kali Linux machine, but we also pretend to be the router. We typed the router's IP address instead of our own. And this packet is being sent to this destination. Now, before I send it, I'm going to open the command prompt on my Windows 10 machine, and I'm going to run the arp-a command from the previous video, just to see how the ARP tables are currently being set. So we can see that the router, which is in my case 192.168.1.1, has this MAC address. Our Kali Linux machine, which is 192.168.1.10, has this MAC address. And you will notice once I send this packet, this IP address, which is our Kali Linux, and the router's IP address will have the same MAC address. And that is an indication that the ARP spoofing attack is taking place at that specific time. So let's send the packet, and to do that we can use the send function. The first argument is going to be the packet, and we can set the verbose to be equal to false, and press enter. If I go back to command prompt and type arp-a again, we can see now router has the same MAC address as our Kali Linux machine right here. So we successfully ARP poisoned the ARP cache of our target machine. Now that we did this, you probably now fully understand how ARP poisoning works. And you can also take a look at different tools online to see if there are some better tools that you can use to perform man-in-the-middle attack. Some of them have more options, some of them have less options, but nonetheless, this is all it is about this attack. You simply just send a malicious ARP packets and redirect the connection to you. So thank you for watching this video, and I will see you in the next section.